In this section, we can talk about the matched pairs test, and that will happen when we have a set of data and the sample data is actually dependent. That is, they will consist of a matched pairs, and that happens when the values are somehow matched or based upon some inherent relationship. So a very common one is if you take two measurements from the same subject, so for example, before and after data, or there can be meaningful relationship data between a parent and a child or between partners. Now, what the types of studies that the matched pairs test works with, it allows us to compare the actual differences in an experimental unit. For example, we could ask the question, did a cholesterol medication reduce cholesterol levels in patients? There are some requirements to performing this test. The sample data should be dependent or matched pairs. We will need a simple random sample. And then we need the number of pairs to be large, n is greater than 30, or the matched pairs of values should come from a population that is approximately normal. There's a lot of notation to these formulas. We will let D represents the difference between any two values in a single matched pair. We'll be looking for the population parameter, that is the mean value of the differences for the population. We'll do that by looking at the sample statistic for the mean value of the differences. S sub D will be the standard deviation for the sample, and N will be the number of pairs in the sample. Once we do that, then we can form our test statistic. It again comes down to this is the observed value, and this is the expected value, and this will be the standard error. Now, when we do this, we'll use the hypothesis test. It will be a t-test procedure, but we'll do it for a single population mean. Since this will be a single population, then we'll use the the degrees of freedom will be n minus 1. And the confidence interval will be then the sample data average minus the error and the sample data average plus the error. All right, so let's see how this works. A study was conducted to investigate how effective a new diet was in lowering cholesterol. Results for the randomly selected subjects are shown in the table below. The differences have a normal distribution. Are the subject's cholesterol levels different on average after the diet? Let's test at the 5% significance level. Okay, so here we're given a bunch of data, and so we're going to do some calculations with our calculator. So first, let's write the claim. Okay, now this one might be a little well, let me just show you. Okay, so are the subjects levels different on average? Okay, so we're going to just think about the differences here. So first of all, let's calculate these differences. Let's put this in L1, and we'll put this this data in L2. Now we could create the third column L3, which is the difference L1 minus L2. So our data set is what we actually come up with calculating here that we will use. So the differences are 10, 3, 16, minus 11, minus 1, 15, 27, 17, and 21. So our claim will come and say, are these levels different? So we're making a claim about the population parameter, mu sub D. We want to show that there is a difference so that that does not equal 0. And then we'll go through the same procedure. We can assign the claim mu sub D does not equal 0. That does not contain equality, so it becomes the null hypothesis. The alternative hypothesis will take the opposing viewpoint that says the mu sub d will be equal to 0. That is, that there is no difference. Then we can state the level of significance of this test. We're testing at a 5% significance level. The null hypothesis has the not equal to symbol, so this is a two-tailed test. After that, we can determine the sampling distribution. We are told that the population is normally distributed and we do have matched pairs, so we do have dependent data, and that will allow us then to conduct not the two-sample t-test, but the one-sample t-test. Okay. So from there, we need to determine the critical values for the rejection region. Now, to do this, we need to know the degrees of freedom. Remember, the degrees of freedom are equal to n minus 1, which we have 9 matched pairs, subtracting 1, so the degrees of freedom must be equal to 8. And from there, then we can put that on our diagram. We want a 5% significance level, so 0.025 will be in this tail, and 0.025 will be in this tail. Using the table, we can see the critical values are 1.86 and negative 1.86. Next, we need to determine the test statistic. So t will be equal to mu sub d minus, the sample average differences minus mu sub d divided by the standard deviation for the sample over the square root of n. So mu sub d, or not mu sub d, d bar is the mean of L3. So to get there, you're going to have to go to stats, or second in stat, that will get to the list menu, and from there go to math, and you'll find both of these functions there. So we see then that the mean is 10.7778, and we're going to subtract off mu sub d. Now we've made the assumption that mu sub d is equal to 0. Then we'll calculate the standard deviation. We get that from the calculator, 11.8615. We divide that by the square root of n. There are 9 in the sample. So when you do this, we would get 10.7778, and we divide that by 3.9538, and that will get us a test statistic of 2.73. Okay, so this goes on the diagram. And we can see that already that this is in the rejection region, but we'll calculate the p-value. So we need the p-value for both ends using symmetry. So we can calculate then the p-value. So we leave it in both tails. You can either calculate 2 times the probability that t is less than negative 2.73. That's the same thing as 2 times the probability that t is greater than 2.73. And when you put this in your calculator, you should get 2 times 0.0129, or our p-value would be 0.0258. Now we can make our conclusion either based upon the critical value or the p-value. Either way, we will reject h sub 0. The reasoning for the p-value is 0.0258 is less than alpha at 0.05, or because our test statistic, which was 2.73, was greater than the critical value of 1.86. That is, it is inside the rejection region. And then we can translate the results of this into our formal sentence. So at the 5% significance level, there is we are rejecting the H sub 0. So there is sufficient evidence to support the claim that subjects' cholesterol levels are different after the diet. We could also calculate the confidence interval for this test. We would use we would go to stats, tests, and then use the t-interval. Just recopy the information and how you will need to put it into the calculators. And when you do this, you should come up with 1.66 is less than mu sub d for the difference less than 19.90. So what does that confidence interval suggest about the claim? So the claim said that the null hypothesis said that there was no difference. The claim said there was. So since 0 is not in this interval that we calculated, the confidence interval, there is sufficient evidence to support the claim that there is a difference in cholesterol levels after the diet.